show you some information that I've got in other places, and then I'll open it up to questions. This video will be recorded, so if there's anything that you didn't catch or can't remember what I said, you can go back and look at it. It'll probably be up and visible sometime later this evening. So the midterm, good. The final is tomorrow. There are 2 time slots for the final. I've already sent out an email. I sent it out in every possible way I could think of getting it to you. So you've probably got multiple copies of it, but some people have one email works and the other doesn't, kind of thing. So I tried my best to cover all possibilities. So it's tomorrow. There are 2 time slots for it. Let's see if I'm making sure I'm telling you the right time slots before I get too caught up in it. The first one is you can start the exam any time between 7 and 9 in the morning. We call that the morning time slot. The exam lasts 3 hours and it's got 20 questions, not 25. Midterm ended up being, I think, a bit too long for some people for the 3 hours. So I've knocked it down to 20, but there won't be any extra credit now. I gave you extra credit to make up for the fact that you might not have had enough time to do the final, for some of you anyway. So there's going to be 20 questions. It's fully comprehensive. So the first question you're getting is from question chapter 2, right, the first week. And the last question you're going to get is hypothesis testing at 2 means, difference between 2 means. Although it's fully comprehensive, 60% of the points are on the last 4 weeks. That's chapters 10, 11, 12, 13. So 60% of your points are chapters 10, 11, 12, and 13. And if you want reminded about those are basically the confidence interval and hypothesis testing stuff. So you know you're going to get pretty much a question on every single one of those things. So you're going to get a question on a confidence interval of a single proportion and the difference between 2, and a hypothesis testing on a mean and the difference between 2 means. Kind of a bit of, you know, all the major points will be hit. So expect a question on all the different kinds of hypothesis testing. There's 4 of those. Single proportion, difference between 2 proportions, single mean, and difference between 2 means, right? That's the 4 hypothesis ones, and there's 4 confidence interval questions. And I don't know if, yeah, there's probably a couple of other questions chucked in there which are more generic. So bear that in mind, but the other 40% is from the first half. So you will get some questions, but nowhere near as important in points at least, but you want to make sure you're ready for them as well. Now, when you're finished, and that's the morning one. So if you start anytime at 7, let's say you start at 7, you'll be finished at 10. If you start at 9, you'll be finished at 1 o'clock, right? Because it's 3 hours. But you won't, you'll be finished at 12, but you know what I mean, 3 hours later. It's all in WebAssign, nowhere else, just WebAssign. So when you come in and I see you, you'll hit the button and you'll do WebAssign. And you know WebAssign's got a clock on it. The minute you hit it, it starts ticking. So don't even hit that button until you've kind of got yourself, you know, your cup of coffee and your notes in front of you and all that good stuff. So you don't end up, wasting 10 minutes before you even really get started. Try and do as much working for those questions that it's feasible to do working for, because those are the ones you're going to take copies of and send to me at the end in the usual place online in Canvas. So you know the ones where you take your pictures. Some of you did really good on that, and some of you might have noticed that you got a lot of points because of that. And some of you gave me 2 questions. And as much as I'd love to, I can't give you points, so there ain't anything there to see. So you got to be able to show me everything that you can. Now, you can't show me working on every question. Totally understand that. A lot of questions are, you hit the salt button and you make sure you put the right numbers in the right places, right? There's not anything that you can show me there, and that's fine. I don't expect to see anything. Just be careful when you do that, that you don't switch numbers around or whatever. But there are questions where you do working. There's the questions that you've seen in homework, find the standard error. Right? There's not a salt button there, which is a good clue that you probably could show me working. Right? Show me the working. Show me what you did. What was the formula they used? Where did you put the numbers? Here's my answer. That kind of working. And that gives me a good idea that you know what you're doing. So the second chunk of time is 4 to 6 p.m. So I'll call that the evening one, right? So the morning one is 7 till 9, and the evening one is 4 till 6. So anytime from 4 to 6 you can start. And so you could end up finishing at 9 p.m. if you were a late starter because you work in the day. Same rules apply. I need to see you physically as I can see you now. So Alice has very kindly gave us a PDF of her notes from chapters 10 to 13. So if you know how to do that, you click on, is it click on chat that you get things like that? Right?
Yes.
So so if you click on chat, you can click on it and download our PDF notes. And I think that we're doing, this is students that are doing this. This isn't anything that I'm having, you're getting together and doing like study session where you ask each other questions. And I think that's very helpful. I find that students, when they describe things to other students, use it in a language that they each understand, and it makes it a lot simpler. So sometimes you can talk to each other. What is this and what does it mean? And somebody tells you and you think, okay, why didn't he say that? Right, I understand that. So I have nothing to do with that, because I think if you talk much more freely, if it's not recorded and I'm nowhere near it, right? It's just like you're meeting in the hall and you're chatting about homework and, getting ready for the exam or whatever else. So I think that's at 3 p.m. I did send out the link for those who are interested in it. And quite a lot of people saying some days very, and yes, anything that's physically written down you can use, including her notes. And hopefully you have got your own notes. There are different people work differently like this. I've seen people who just have sheets of paper with all the formula that they need to use, from like all the different flavors of standard error formula, for example. And some people do an example question and then how they solved it. That would be their kind of way of doing notes. Some people just write verbally, things to remind them how to do things. I mean, you know how your brain works, you know how you learn. But, if you can write it down or print it, it's acceptable for the test. You're also allowed to use your calculator. And obviously, you'll be able to hit the salt button, because in your final exam, there are questions where you do that. And there are a lot of wow and amazing. I need to see those notes. I'm going to probably steal them as well eventually. Okay, I think there's maybe a natural pause now that I've kind of given you the big picture, right? The finals tomorrow, the 2 time slots, it's 3 hours, 20 questions, 60% on, the chapters 10, 11, 12, 13, the other 40% on everything else. Any questions in that general area right now before we move on to show you what's on Canvas, and then I'll throw them to questions again. Any questions right now?
How many questions did you just say were going to be on the test?
20, Nathan.
That's 20, okay.
Okay. Are we good then, right now? Right. So I'm now going to show you what we have on Canvas, and hopefully you'll use this as a resource, something you can, excuse me. Oh, wait. I'm expecting a phone call. Not that one. That was a scam one, I believe. Right, here we go. And I should share it. And here we go. Right, you should be looking at Canvas page. Does that look right?
Yep.
Right. Now, if we click on the first one, which is final exam information, some of this has got placeholders because I haven't filled it in. But that top one is the PDF of the notes that I sent out yesterday by email. You know, the one where I told you a lot of what I've just mentioned about when the exam is, how many questions it's got, and so on, right? This is the Zoom link to get here. So I sent that out. This will be the video of what we're doing right now. So if you forget anything and say, I wonder what you said again, I'll go back and look at the video and find out. It will be there sometime. This one here is the link that you will use tomorrow when you're going to do your exam, your final exam. That's the Zoom link for it. There's some notes on and videos to watch on how to do Adobe Scan. And this fella here, upload working for final exam here. So you remember we did the same thing for midterm. You click on that and you can upload your working so I can look at it. That's where it goes. That will be there on the day of the final. This one here will disappear sometime Thursday morning. But essentially what we have here are all the notes, all the lectures of every chapter. And I've reorganized it a little bit differently. If you click on this one, and then you click on that, can you see that we have various people who've turned up for officers and asked questions? Here are the videos. So for instance, 13A question 1 and 2, 13A question 5. There's some things on how to do hypothesis test and so on. If I return out of this one, if you, well, I don't know, if you do this one, what we have here are video lessons that we got from weeks, I think that was last week, I think. And if you click on something, say like that, here's a P, or should be, I hope. Oh, that's a video. Oh, no, I'm not. Good. Here is, here's a PDF where I just go and tell you the gist of what's in that chapter, and probably some more. I always give more. And that's a resource, right? Things you can use. That there is just a duplicate of the last 2 weeks' lessons. Basically, this has all the confidence intervals and hypothesis test stuff in it. And this one here is some practice tests and solutions. So if I click on this one, it's a PDF. And open it up. Now, it's not quite the same as the final, but it gives you an idea of some of the kind of topics and questions. And then if you scroll to the end, eventually, keep scrolling. There we go. There's the solutions. So it doesn't do sort these questions. This is really just to show you what questions look like and how you do them by hand. But they're still worthwhile, I think. So there's lots of different resources for you. Now, when the final happens, all these guys disappear. When the final happens, all homework assignments disappear. The only thing you will see on tomorrow is going to be the final exam. That's the only thing that will be left, right? So when you go to your website, it'll be kind of sparse. So make sure that you've got good notes as soon as you can. That's it now. Q&A. Start asking me stuff. Anybody? I doubt I'm that good.
Does it have to just be about the exam, or can it be literally about anything in terms of statistics?
Well, go ahead. Just chuck it, whatever it is. What's in your head?
Well, I mean, I understand what the p-value is.
Yes.
I mean, I get it's, but what if they don't give you the significance, like point?
Right. If they don't, I've came to the executive decision. It's 0.05 if they don't tell you.
Okay, that's what I assumed.
And they should really tell you, but yeah, sometimes they, for weird reason, forgot to.
So it's kind of like with the confidence interval of just 2%, or I'm sorry, just 2. Like if they say
when normally they say something like approximate confidence interval or something, the key word here is approximate, and when that happens, you use 2. That's a different situation, but yeah, you use 2 in that.
Okay. And then as for the p-value in general, I'm just, like I said, I understand it has to do with, the significance of whether the value is how, I guess, accurate or how substantial it is, but I still don't understand it.
The way I see a p-value is it's a probability that you got the sample that you got. Now, if you make the assumption that there's nothing going on here, right? That nothing has changed, right? So that the world is exactly as it was last time, which is what the null hypothesis says. The null hypothesis says nothing you see here, nothing's changed, right? So what the p-value tells me is what's the probability that I got a sample that was the one in front of me? How unlikely that is. And if it's extremely small, that's evidence that you did it. Right, and by mean you did it, that's evidence that the null hypothesis, the status quo is wrong, and whatever you believe the alternate is true. Analogy. If there's 1,000,000 to 1 chance that you are innocent, aren't you probably going to be in jail? If the evidence is so strong against you, that the only way that that evidence could have been just sheer bad luck is 1,000,000 to 1, right? You're probably going to end up in jail. Isn't that the kind of evidence that convicts people? So you kind of you turn the idea on its head and you say, if p is really small, a really small number, that is so unlikely that the opposite, whatever the opposite thing is true. So you can't be innocent. That's too unlikely. So you have to be guilty. You can't be innocent. P is so tiny. So small p-values are our goal, if you want to think of it as a thing you want to see. Because if the p-value isn't particularly big, like 12% or 40%, that's pretty much the kind of thing you would expect if nothing interesting was going on. But if it was 0.5% or 0.0002 or something tiny, that is too rare an event to be luck. So there must be something else going on. And that's, you just have to have your mindset in a kind of like reverse thing. People would think P should be really big for evidence, but it's the exact opposite. P should be really small.
Yes, maybe that is what's been confusing me, is why would you want a smaller value for better
proving something? Well, yeah, that's what we get as a small value. If it makes you feel better, isn't one takeaway that number really big?
Okay, yeah, so that's why it's like,
and that's called, that number actually has a name, but we don't use it. It's called the power of a test. And so if the power is really big, because if P is 1%, the power is 99, right?
So that's
You're 99% chance of being guilty here, guys.
okay. That's
Anything.
what I needed to hear right there. Thank you.
Although we don't use the 99, we use the
Yeah.
1% side.
Which is totally,
It's the logic of how it works. You just have to kind of get used to that. That
got
was
it.
a good question.
So
Right.
apparently, Sydney Wood was asking if we could do some practice questions.
Well, we could do anything we like, Sydney. If you get any idea what kind of practice question you want.
I was just thinking chapter 10, 11, 12, and 13, since that's the most,
That's a lot of practice questions, and
no, not all of them.
so anything from any one of those.
Yeah,
The good news is that there's questions in all of them in the final, so no matter which one I do, you're going to get a question on it. So I don't feel so bad about picking one. I preferred you said, even if it was random, oh, do something from hypothesis testing or whatever, then I would do that. But have you got any particular one that you would like more than the others or whatever?
no, I don't care.
Don't care. Okay, let's do hypothesis testing. Do you want means or do you want a hypothesis test with percentages, i.e. proportions? Which one do you want?
Let's do percentages.
Okay, so we're going to do proportion, which is percentages. So I'm going to do a proportion story. Right, so that'll be, if I remember, is that 13, 12, I can't remember. 12. It's 12. It's 12 A, B, and C, isn't it? Yeah. So you'll get them in chapter 12. Do you want a 1 or a 2? Do you want a hypothesis test where there's only one proportion involved, or do you want one where there's 2?
I don't care.
2 then. So that would make it, I believe, 12C. Okay, so we'll have a story about 2 different populations, and we're setting up a hypothesis test to test the difference between them. So you don't know this because I'm making it up, but in Japan, the percentage of people who are lactose intolerant is estimated. So what they did is they got a sample, we'll call it N1, of 200 Japanese adults, and they tested them for lactose intolerance, and they found out that 181 of them out of 200 were lactose intolerant. And that's my population 1. And Scots people, N2, they got, say, 300 in that sample, and the percentage of those who were lactose intolerant was 18. Let's make it 180 out of 300. Okay. And we are being asked in this story, is there enough evidence to prove that Japanese people have a higher lactose intolerance rate, right? In other words, they can't take milk products, right? More than Scottish people. Now, if I turn this guy here into a decimal, it'll kind of make it a little bit easier to see the comparison, in which case, it's about 91% of Japanese have problems with milk products, dairy products. And that's a nicer number. It's about 60% for Scottish people. Now, although I have made this number up, I remember one of my students who were doing this, and it caught my interest, and so I looked it up. Do you know that people like me who are Celtic from Northern European stock, we have a very, very low, we can drink milk and dairy products. We got a genetic mutation that tends to make it pretty easy for us to do that. Japanese and Asian people do not have the same amount of people who have that genetic variation. And so this is actually true. Japanese people in general would find it very difficult, a lot of them, to drink pure milk. It would upset their stomach, right? Their their bodies can't cope with the process. So although these numbers are made up, the truth is actually pretty good. So this is people who can't take milk, 90%, and in Scotland say it's 60. Now, when you get one of these stories, you'll be given a significance level. Let's say it's 1%. And if they don't tell you in the WebAssign question, well, you assume that it's 5%, 0.05. So we are going to do the entire hypothesis test on this data. This type of question could certainly be a solved question. Probably would be, right? So what I'm going to do now is I'm going to nip over, if I can, and find salt and use that. I'm just loading up WebAssign. Now, the hypothesis test has a number of steps to it. And in some questions, they actually kind of ask you all the things that lead you through those steps. Like they'll ask you to find this and they'll ask you to find that. And which is, I like, which is a good thing for you to do. I'm going to close a few windows off here. I need to move this a little bit. Here we go. Almost there. Now, I've lost you. I've closed too many windows. Where are you? There you are. Okay. So, I am ready to show you what's going on. I'm going to use this fella here. Ignore the story because this is my story, right? But we're going to use this guy to put all that information that I gave you into a format that we can use. Now, the null hypothesis, right? P1 take away P2 equals 0. Now, to get P1, you're going to go P, hit that funny little button, 1, subtract, P, hit the subscript button, 2 equals 0. What we've just said here is that the difference between the Japanese and the Scots is 0. In other words, we're making the assumption there is no difference about intolerance, right? Both groups of people can drink milk equally good or equally bad, right? No difference. When you do a difference between two proportions, the null hypothesis is always P1 take away P2 equals 0. It's not going to change when it's a difference between two proportions. If it's a difference between two means, won't it look virtually the same, but it'll be called mu1 take away mu2 equals 0. In other words, the means are the same, right? Now, in my story, I wanted to get evidence that the Japanese had a higher intolerance rate than Scottish. So that's going to be also P1 take away P2. And then you have a decision. Greater than 0, less than 0, or not equal to 0. Doesn't that depend on the story? We were wanting to prove that the Japanese had a higher intolerance level, right? Higher, more than, greater than 0. Now, if the difference is greater than 0, isn't that mathematically the same as saying P1 is bigger than P2? Right? Japanese is 1, right? P1 Japanese greater than P2 Scots. But you notice you don't say it that way. You say it as P1 take away P2 greater than 0. That's just the way we set these things up. So far, so good? Any questions about that? The difference is 0 is the null. The difference is greater than 0 because we want to prove first guy is bigger than second. If we wanted to prove it was less, right, the other way around, right, Japanese had a less rate than Scottish, wouldn't we just say P1 take away P2 is less than 0? And if we wanted to prove that they were different, and that's all, different, who cares how, wouldn't you do P1 take away P2 not equal to 0? They're called left, right, and two-tailed tests, if you want to know their names. Right, now I'm ready to hit salt, hopefully. And I'll bring salt over this window. I use looking at salt. Yeah, can you see a salt picture? Okay, now, depends on what hypothesis test we're doing, which version of the data we're going to use. Inferential statistics is the tab that you use for hypothesis tests, right? Inferential statistics. Now, the choices I've got are these guys. When it's 2 samples and it's proportions, we're going to use 2 sample proportions. So that's the right one to tick. If it was a single proportion story, right? One country, Scotland, used to be this number. We've waited 20 years and we've retested them when we think it's changed, right? One of those kind of stories, just one proportion, right? One sample involved. Then I would use 1 sample proportion. If it's anything to do with means, right? The mean in one place, the mean in another place, anything to do with means, it's either 1 sample T or 2 sample T. So you've got 4 choices depending on which story. 2 proportions, 2 sample proportion, single proportion, 1 mean, difference in 2 means. Right. We're doing 2 proportions, that one. The first one is the Japanese, and they are 181 out of 200. The Scots come next, they're 180. Oops, don't know what I'm doing. 180 out of 300. Now, 2 more boxes and we're good to go. This box says hypothesized difference. This is basically H naught, and it's always going to be 0, so you don't need to change it. When it's a difference between 2 proportions, it's equal to 0, at least in the situations we're dealing with. Now, what about an alternate? Wasn't our alternate that the Japanese was greater than the Scots? So you see why I chose greater than. So this is essentially what the null hypothesis, that's all you need to tell them, it's 0. And this is the alternate hypothesis, and all you really need to do is tell them that it's a bigger than. So when I hit generate results, over here on the right are going to be all the numbers that we need and some. Now, can you see my P1 and my P1 greater than? Do you see that's just exactly the way I wrote it down? Right? Are we good?
Yeah.
Yeah, okay. Now, there are lots of information here, but the key number that we're really interested in is the p-value. You see this guy here? And would you agree that number is pretty much, for practical purposes, 0? It's 0.0001, or actually it's less than that, but it's so tiny it's almost not there. Sometimes they ask you for a test statistic. Have you seen homework questions where, what is the test statistic? That's the Z-score, right? So I'm moving this fella away now. The test statistic in my story then was 7.457. Put that in. Oh, to 2 decimal places, so 7.46. And if I'm doing the p-value to 4 decimal places, technically it's 0.001. Well, I was right. We agree it's darn well 0 for practical purposes. Okay, now what does that tell me about my hypothesis test? Well, I'm going to come back to this a little bit at the end, but let's do it on kind of paper. We've found out by using SALT what the p-value was, and we got a p-value that was some number like that. And what we should do is our test, and our test is the p-value less than the significance level? So that was that. If it's tiny, it's proof kind of result, right? Is 0.00001 less than that guy? And the answer is yes, it is. And that means we can reject the null hypothesis. When you reject the null hypothesis, right, which is this guy, it means then that the other hypothesis must have been true. When you have two choices and you say it can't be the first one, then doesn't logic mean it has to be the second one? Right? There are only two choices, right? You did it or you did it. It can't be you, so it must be the other guy. Right? That's the kind of logic behind it. So when we say you reject the null hypothesis, we say you're no good. So even if you don't explicitly say it, when you reject the null hypothesis, you're also saying that P1 is bigger than P2. So yeah, we've shown that Japanese do have a higher intolerance level. So how does that look like in a homework world? Well, they have one of those menus where you choose from a list of words, typically. So maybe make this a little bit bigger. I don't know if that's going to help Arinda. Okay, since the p-value is less than the given significance level, we would reject H naught. This means that there is sufficient evidence to conclude that a higher proportion of Japanese have intolerance than Scots. And that is pretty much from start to finish what a hypothesis test looks like.
Thank you.
Try and, if you can, try and think of this as a process, like a step 1, step 2, step 3, step 4. The step 2 I missed in this question because they tend to miss them a lot in homework. The step 2 is I should check that I'm actually even allowed to do a hypothesis test on it. And those would be questions like the samples were random, which they were in my story. And there's a thing that I call the 10 rule. Can you remember what the 10 rule is? What was the 10 rule? You may be saying something, but I can't hear you.
You need to have more than 10 people.
Yeah, that's what I was saying.
That's it, right. So then you need to have more than 10 people who said yes and more than 10 people who said no. And that's phrased as NP1 and greater than 10 and N1 minus P, right, is greater than 10. So that's the 10 rule. So you want to make sure that you have a random sample, that the sample is big enough, the 10 rule, and very often other things pop in and out depending on whether they go into the details. Shouldn't it be an unbiased questionnaire, right? So I don't think you could screw up. Do you have, are you lactose intolerant or something? I think that would be a pretty easy one not to get bad data from. But there are questions you have to be careful about. If you ask people illegal activities like drug activities, you don't always get the truth. So you could get problems along those lines.
Why, yes.
So Any more questions?
I'd like to do a
Is-
screen share if nobody else is wanting to, or nobody else has a question.
So I have to get back to work. I just want to
Okay,
know, when
Tina.
will we know our final grade?
So yeah, that's a good question. Well, I can tell you when you'll have to know it. You'll have to know it by midnight on Friday, because me and my wife and my in-laws, we are having a vacation and we're off to Vegas. So I'm off to Vegas to do a practical probability survey on how much money I can lose at any given time.
Cha-ching,
gonna-
Professor, cha-ching.
Right.
Reject
So-
the no.
So don't turn up and tell me, oops, I thought it was next Thursday, because I won't even, I'll be honest with you, and my wife will make sure I keep to this rule. I am not going near my email, because if I go near my email, it will screw up my holiday. I haven't been home to Scotland in 2 years, and it's driving me stir crazy. I need a holiday. I need to, as much as I love you guys, I need to have a break where I think nothing at all about school or anything. So I won't even look at my emails. So it will be done by midnight on Friday. My goal is to get it done sometime roughly about Friday afternoon, right? So that's when you should be able to see it. What I'll do is, do you know those emails I send you out that tells you your report? You know, your week 6 report and that kind of thing. Remember those ones?
Yep.
Yeah, you'll get one as soon as I've got it finished. You'll get one of them that I'll send out, which will have your everything in it, including your final grade, so you'll know what it's like. And bear in mind, you've got till tonight to get 13A and 13B finished. There is no extensions. Right, everything finishes at midnight on Wednesday as far as schoolwork goes, and the final finishes on Thursday, depending on when you do the test, the final exam.
So you know how like there's 20 questions. Is it like 10 points per question, or? I mean-
No. Well, that would be 200 points to start with. It's broken into percentages, so it's not even points in the sense that you'll get a result like you got 82% in the final exam. So the questions, they're only 100 points, right? So 60 of those points are from chapters 10, 11, 12, and 13, and 40 of those points are from the rest. So that's how it's going to work, and then that percentage is weighted according to the weighting system to give you your final grade.
Got it. Thank you.
Okay, bye-bye, Tina. I'll see you tomorrow then.
Alrighty.
Right, I think Edwards was going to share, but we'll kind of make his the last thing, because some of you might want to go after this and might or might not want to see what Edward's interested in. I'm interested in finding out what it is, but that's me.
I would like, I have two real quick questions.
Yeah.
One about contacting you, because I know you're probably going to be busy on Friday grading, would be my guess, right? You're going to be.
Yeah, I'll be a hermit. I'll lock the door and just throw things at anybody who tries to come in. So
Do you have,
anybody.
Is there any way to contact you on Saturday in case, because you're probably going to be busy on Friday?
No, on Saturday we are getting the opposite of a red eye. I guess you could call it a green eye. We're leaving like the first flight out, so you won't be able to. You won't even see me on Saturday.
Okay.
So what is it you want to? What kind of information, if it's something you want to share right now, that you're interested in?
I remember last time I had problems with the grading, so I just wanted to know if there'd be any way of contacting me at all.
If the grading issue happens, nope. But it doesn't mean that your grade is wasted forever. When I come back, I can change grades anytime.
Yeah.
You may have to wait 2 weeks because that's how long we're gone. But when I come back, I will start looking at my email and finding out what's happened. But hopefully that doesn't happen. And we'll go for the positives that won't happen. If I get it out to you on Friday afternoon and you are waiting for it, you could contact me immediately on Friday and I can look into it. Right.
Yeah. And I have one quick question as well
Hmm.
for for section 7 about probabilities.
Yeah.
Um,
You want to share?
yeah, I would remember how to do
Okay.
this one time.
Here we go. You bye-bye then.
Yeah, I need to go.
Okay, bye-bye guys.
Goodbye.
What you got for us?
For number 2 here, I wanted to remember. I'm trying to remember the exact specifics for how to get this fraction again.
Okay, let me see. Suppose that a magnet school includes grades 11 and 12 with half of the students in each grade. 90%, so that's 12th grade, right? 90% of them are senior class and 50% of the junior are taking calculus. And then it goes on, it does suppose a calculus in. So what I'm going to do is I'm going to set up that information in the form of a tree diagram. And so we're going to have 11th grade, which is junior, and then 12th grade, which is senior. I know you can't see this, but you will see it in a little while. And then we'll have calculus and not calculus. And then we'll have calculus and not calculus. And 50% are in each group, so I'm doing a 0.5 in each. And then the calculus ones, half the senior and 20% of the junior. So half the senior take calculus and 20% a the junior. Let's check that out. Yeah, okay. So all that information and what you're wanting here is, suppose a student is random selected. So you're told it's a calculus student, right? So it's given that it's a calculus student, okay? And what you've been what's the probability that they're a junior? Okay. So we're being asked to find what's the probability that you choose a junior given that they take calculus. Right, we got everything I need now. Let's show you how we would do that question. Right. Half are juniors, half are seniors, 0.5, 0.5. That mess up here is 0.2 of the juniors took calculus, 0.5 of the seniors took calculus. If 0.2 took it, isn't that also 0.8 did not take calculus? And is 0.5, that makes this 0.5. And what I'm now going to do, I'm going to see if I can change pen colors, is we're going to get the end probabilities of those 4 combinations. So 0.5 times 0.2 ends up being 0.1. 0.5 times 0.8 is 0.4. 0.5 times 0.5 is 0.25. And 0.5 times 0.5 is 0.25. Are you happy about how I got those 4 last probabilities?
Yes.
Yeah, okay. Now, we're being asked to find the probability that you're a junior given that you picked calculus. That's a hard probability to do. If I call this the probability of A given B, we can use a thing called Bayes' theorem, which says you can find the probability of B given A times the probability of A, and then you divide that by the probability of B. It's called Bayes' theorem. Do you remember seeing that in the notes somewhere in the textbook?
Yes.
Right. So these guys I can find from that diagram, each one of these 3 things. And these are that guy. Now I'm just going to turn them into what they look like in the context of this. So A is junior and B takes calculus. So what's the probability that you take calculus given that you're a junior times the probability that you're a junior, all divided by the probability of B which is you take calculus, right? So that's what it looks like in the context of this story. Now, all of these numbers I promised you are in here somewhere, so let's find them. The probability that you take calculus, given that you're a junior, is that number there. If I tell you you're a junior, you've already reached here, the chances that you took calculus is 0.2. The probability that you're a junior is this guy. Now, what's the probability that you take calculus? Well, isn't that these two different groups? That lot took calculus and that lot took calculus. So the probability that you took calculus is 0.35. Are you happy about where I got those three probabilities from this tree diagram?
Yes.
Now, if you do the two guys in the top and divide them by the guy in the bottom, we are cooking. So 0.2 times 0.5 divided by 0.35 and roughly 0.2, well, I don't know what accuracy they want, 286, right? Which is about 28.6% of the time